This is Calculus Unit 7, Day 61. Our objective, identify and create slope fields that represent the general solutions of differential equations. Okay, so slope fields. And this is going to seem very difficult, but I think the 58 and 59, second fundamental theorem of calculus, and getting into um, the pattern recognition stuff, that is challenging. And I think almost this first half, separation of variables looks complicated, but as you practice it a few times, not bad. I think slope fields actually very easy to understand later. It's just very complicated when we first jump into it. So graphical representations of solutions to differential equations. So slope field is a pictorial representation of all the possible solutions to a given differential equation. Remember that a differential equation is the first derivative of a function, f prime of x or dy dx. Thus, the solution to a differential equation is the function f of x or y. That's what we just did last section. We undid the derivative dy dx and we came up with the specific function, or the general solution of a function. So there's an infinite number of solutions to the differential equation dy dx equals x plus 3. Show your work and explain why. So I'm first going to do this example, dy dx equals 2x, just so we can talk about this. And let's remember what dy dx mean. It means the slope. So that means what has a slope of 2x? Well, if I did what I just did in separation of variables in day 60, I would bring the dx over, and now we would go through and take the integral of both sides. So hey, this would be y equals, this would be 2x squared over 2 plus c. So our general solution of the function would be x squared plus c. Okay, so what does that mean? Well, I think I used the same example. Well, that means I could have x squared plus 0, I could have x squared plus 5, I could have x squared minus 3. There's an infinite number of solutions. Obviously, they're all the same width. I'm just making them so they don't cross. But so we have an infinite number of things there. But this represents the x squared plus c. So what a slope field does is it kind of allows us, and what we do is we take these, and instead of drawing the whole function, oh, I'm supposed to be having just parts of it. Um, just show parts of where that is. And obviously, all these parabolas have at when x equals 0, the slope is 0. And over here, the slope might be 1. Over here, the slope might be 2. And keep going. And over here, it's negative 1. So you start breaking these down to their individual small components of these little segments. Okay, and that's what we're going to look at. Okay, so let's come back up to this example that they asked us to do. So dy dx equals x plus 3. So the first thing I would do is write it as dy equals x plus 3 dx. We're then going to take the integral of both sides. Okay, and this will be y. This is going to be x squared over 2 plus 3x. I'll just write that out. 1, and what we said last section with this will be normally y plus c. And this will be plus c, but we're just going to write 1c. Okay, so f of x equals 1 half x squared plus 3x plus c. So this is the general solution of dy dx equals x plus 3, and it's going to represent all of the quadratic functions, which are parabolas, that could be f of x for dy dx. And that's kind of what I did in that little example, quickly sketching all the stuff. So the slope field represents all those functions, okay? And there's 4 ways we're going to look at this. So the AP exam, you're expected to be able to do the following 4 things with slope fields. You're going to either sketch a slope field given a differential equation, given a slope field, draw a particular solution, match a slope field to a given differential equation, and match a slope field to a solution of a differential. Okay? So those are the examples we're going to have coming up. All right, I'm going to jump over to part 2. That'll be part 1.